So hello everyone, back again with me Sir Julius. So for today, we will learn about our next topic. We will learn about the operation of an integer exponent. So without further ado, let us start our lesson today. But before we start, I want to explain to you about the difference between two terms. The first term is called bilangan berpangkat sebenarnya, and the second term is bilangan berpangkat tak sebenarnya. So what is the difference between both of them? So now for the first one, bilangan berpangkat sebenarnya. So bilangan berpangkat sebenarnya is when the exponent is positive. Meanwhile, bilangan berpangkat tak sebenarnya is when the exponent is negative, zero, and fraction. So you must know the difference between both of it. Okay, so now we will go to our next topic about the operation of integer exponent. So we already know what is integer exponent. Integer exponent is when the exponent is negative, zero, and positive. But integer exponent can't be fraction. The exponent can't be fraction. So for today, we will learn about the operation of it. The first thing we must learn is addition of integer exponent. So addition of integer exponent, we can use this formula: a times x to the power of y plus b times x to the power of y. So if the base number and the exponent is the same, we can write it as parenthesis a plus b times x to the power of y. So when the base number and exponent is the same, we can add the coefficient of it. Okay, so now we will see the example of it. So I have 6 times 7 square plus 4 times 7 square. Now we see from the question, we can see that the base number is 7 and the exponent is 2. So if the base number and the exponent is the same, we can add the coefficient of it. We can add the number in front of the base number and exponent. So 6 plus 4 times 7 square. 6 plus 4 equals to 10. Meanwhile, 7 square is 49. So we have 10 times 49 equals 490. Now we will go to our next operation, subtraction of integer exponent. It's still the same with addition of integer exponent, but the sign will be changed from positive to negative. Now if we have a times x to the power of y minus b times x to the power of y. So if the base number and the exponent is the same, we can write it as a minus b times x to the power of y. Now for the example, if I have 30 times 5 to the power of 6 minus 5 times 5 to the power of 6, because the base number and the exponent is the same, we can write it as 30 minus 5 times 5 to the power of 6. 30 minus 5 equals to 25. So we have 25 times 5 to the power of 6. Now we will go to multiplication of integer exponent. So if I have a to the power of b times a to the power of q equals a to the power of p plus q. So when the base number is the same, the product of it, we can make the exponent an addition. So when the base numbers is the same, we can add p plus q. So we have a to the power of p plus q. So now we will see the example. Now if I have 3 to the power of 4 times 3 to the power of negative 6. So if the base number is the same, we can add the exponent. So 3 to the power of 4 plus negative 6. When plus meet negative, the sign will be negative. So 3 to the power of 4 minus 6. So we have 3 to the power of negative 2. So we can make it simpler. We can change the negative exponent to positive exponent. So we can change its position. So when we have 3 to the power of negative 2, we can make it 1 over 3 to the power of 2. So we have the result of it 1 over 9. So now we will go to our next operation, division of integer exponent. So for division, we can use this formula, a to the power of p divided by a to the power of q equals to a to the power of p minus q. So when the base number is the same, the division, we can write it as p minus q. So we can subtract the exponent. So now we will see the example of it. 3 to the power of 4 divided by 3 to the power of negative 6. Well, the base number is the same, 3, so we can write it as 3 to the power of 4. The division sign will be changed into negative, so 4 minus negative 6. When minus meet minus, we can have a positive. So 3 to the power of 4 plus 6. So we have 3 to the power of 10. Now we will see another example of it. Now if I have 2 to the power of 4 divided by 2 to the power of 3, the base number is the same. So we can write it as 2 to the power of 4 minus 3. So we have 2 to the power of 1, or we can say that the result is 2. Now we will go to our next operation. Our next operation will be power of integer exponent. So for power of integer exponent, we can write the formula a to the power of p and then to the power of q equals to a to the power of p times q. So when we have operation of power, we can multiply the exponent. So now we will see the example. If I have 3 to the power of 2 and then to the power of 4, we can change it to 3 to the power of 2 times 4. So equals to 3 to the power of 8. Now we will see another example. Now if I have 3a to the power of 2 and then to the power of negative 3, now we will see from inside of it. So the first thing we must do is 3a to the power of 2 times negative 3. So we can multiply the exponent first. So we have 3a to the power of 2 times negative 3 is negative 6. So we have 3a to the power of negative 6. After we've got this, we must change the negative sign into positive sign. So we have 1 over 3a to the power of 6. Now we will change 3a to the power of 6. So 3 to the power of 6 equals to 729. Meanwhile, a to the power of 6 is a to the power of 6. So we have the result is 1 over 729 a to the power of 6. After we learn all of the operations, so now we will see the example of it. For the first example, I have 8 to the power of 3 times 2 to the power of 5 and then to the power of negative 2. So the operation that we must do first is parentheses. So when we face this problem, remember the base number must be the same for us to do the operation. So now we will see the question. Can we make the base number the same? For 8, we can change 8. 8 is equal to 2 times 2 to the power of 3. So we change the 8 into 2 to the power of 3. So the base number will be the same. So 2 to the power of 3 to the power of 3 times 2 to the power of 5, and then all of it is to the power of negative 2. So 2 to the power of 3 to the power of 3, we can multiply the exponent. So we have 2 to the power of 9 times 2 to the power of 5, and then the result will be to the power of negative 2. So when we have the same base number and multiplication, we can add the exponent. So 2 to the power of 9 plus 5, or equals to 2 to the power of 14, and then to the power of negative 2. When we have the power operation, we can multiply the exponent. So we have 2 to the power of negative 28. Now we will go to our next example. 2 over 3 to the power of negative 5 times 2 over 3 squared. So we can see the base number is the same. The base number is 2 over 3, or 2/3. So when the base number is the same, for the multiplication operation, we can add the exponent. So 2 over 3 to the power of negative 5 plus 2. Negative 5 plus 2 is equal to negative 3. So we have 2 over 3 to the power of negative 3. When we have negative exponent, we must change it into positive exponent. So we can change its position. So 2 over 3 can be changed into 3 over 2 to the power of, the sign will be changed. So from negative to positive. So we have 3 over 2 to the power of 3. After that, we can write it as 3 to the power of 3 equals 27. Meanwhile, 2 to the power of 3 equals 8. So we have the result of it is 27 over 8. Okay, so that's it for today. We've already learned about integer exponent operation. So I'll see you again next time. Bye!